afternoon everybody. Myself Argya Jain and I am from 3rd semester CSE department from Cambridge Institute of Technology, Kerkulam. So today the data set that I have chosen is heart diseases. So first in Google Colab I just downloaded the data set from Kaggle and I have just imported OS operating system and then I have from Kaggle I have downloaded it. After uploading the module, after uploading that zip file, I have unzipped it to get the .csv file. And next, I have imported pandas as PD, and I have just created a variable. Here is a variable to read the entire heart.csv. And first, I just gave the print statement for that. So you can see, just to get the gist of what is there in my data set. So we have about age, gender, CPS, chest pain, and that is again in 3 categories. And then I have TREST BPS. TREST BPS is nothing but resting blood pressure. And next is cholesterol, and then fasting blood sugar. Rest ECG is nothing but your electrocardium during the resting state. This is all medical related terms. And the next one is maximum heart rate, and here I have target. Now target is a categorical variable. Categorical variable in the sense you will be able to categorize your data sets into different categories. Like here 1 indicates that there is presence of heart disease and 0 indicates that there is absence of heart disease. So you can categorize the whole data set and analyze whether the person, there are more number of individuals who are having heart disease or they do not have the heart disease. As told, head will get the first 5 rows, so from 0 to 4, and next tail will get last 5 rows as shown, and next we have print. In the whole data set I have printed the minimum, the maximum, then we have found the mean, median, standard deviation, and also the variance. This is for the entire data set, so you can just see. Next, I have imported Seaborn as SNS, and where Seaborn has many different types of graphs. You can use them to plot different types of graphs. In that first one is your distribution plot. So distribution plot is used for any single variable. So in this case I have used the cholesterol level. So the graph, it's here. So you can see that first there are discrete values, that is for cholesterol, the x-axis is cholesterol and the y-axis is density. Density in the sense probability density. So you can see that the peak is at around 0.008 and the cholesterol level is 200 to 300. So in that interval of 200 to 300 cholesterol level, the maximum probability density could be found. And the curve is called as KDE, kernel density estimation. So because the values are given in discrete, like just the columns, you will not be able to understand or analyze anything from it. So that curve will indicates a smooth continuous distribution. So with the help of that you can find out the peak and how the symmetry goes on. Next we have used pair plot. In pair plot I have taken a categorical variable. As I told, target is used whether there is presence of heart disease or absence of heart disease. So here palette is nothing but just a color indication. I have given you a hustle. So you can see that in that pair plot, the entire thing, what you can analyze is for different values, like when your cholesterol level is in so much, whether you will have the risk of heart disease or not, or say your fasting blood sugar value is so much, it has exceeded so much, or your blood pressure is so much. So based on all these criteria, you can decide whether you have heart disease or not. So that is how I have taken a categorical variable here. Usually pair plot will be used to pair here I have used categorical variable to analyze for every aspect, every criteria, whether we can find whether the person has heart disease or not. And next is correlation matrix, which we'll be doing in the next. Yeah, next is hist plot, histogram plot, and here again I have taken TREST BPS. TREST BPS is the resting blood pressure. So we can see that when the value is between 120 to 140, that is when the blood pressure is between 120 to 140, the count is high, that is the bar graph, you can see that it is the highest for that interval. This indicates that in your data set, there are more number of people whose count, that is who have the blood pressure between in the range of 120 to 140. So maximum number of people have their blood pressure in that range. So that graph will, that bar graph indicates that, and then gradually decreases. This means because it is a data set of heart disease, for heart disease basically your blood pressure will not be normal. So it will be usually high. So in this case also 120 is the normal blood pressure. So above 120 indicates that you have more chances of being risked by heart disease. So that is why 120 to 200 range only maximum number of people have high blood pressure. Next is scatter plot. Scatter plot is used to compare two numerical variables. So in this case I have used age and cholesterol. So and I have also used a hue, that is gender. So 0 will indicate that it is female and 1 will indicate it is male. So blue colors here are indicating that it is male. So here what you can analyze is the graph, I mean the scatter points are more crowded around 50 to 60 and plus, so on. So this means that in your data set, the individuals around 50 plus, they will have the cholesterol level 200 plus. Again 200 is the normal cholesterol level, so above which they have high chances of getting the heart disease, and that is plotted here. And you can see that there are more number of blue dots compared to green. This indicates that in that particular data set, more number of male individuals have higher cholesterol value when compared to female. So this also means that their chances of heart disease is higher for male when compared to female. Next is the box plot, again for age and chest pain I have given. Here chest pain 0 in the sense that there is no chest pain for that individuals, and age group is as told that these two lines indicate that in a given particular interval of time the values will be fluctuating in that range. So for like aged individuals from say around 50 to 60 to around that, there are no chances of getting chest pain, I mean they don't have chest pain. One is the chest pain is because of insufficient supply of blood to heart, and 2 indicates that the chest pain doesn't have any typical characteristics as such, and 3 indicates that the chest pain is present but it is not because of the decreased blood supply to the heart. So this is what we have plotted, and with respect to age we have plotted whether they have what kind of chest pain they have, what category does it fall into. Next is Violin plot. I have used exsange. Exsange is exercise induced angina, that is the chest, the pain caused because of heavy exercising, and this thalage is nothing but maximum heart rate. So what we can see is in this graph, so people having chest pain that is not due to exercising, 0, that will be 0. You can see that maximum data in your data set, it is around that, say 160 to 180. In that range, people who don't have this exercise induced angina, their heart rate will be from 160 to 180, most of them. I mean majority. And next one is people having exercise induced angina. So there you can see that the data is high because obviously this is heart disease data set. So people having maximum heart rate and exercise induced angina, they will be more riskier to get the heart disease. So that is why there is more wider in the graph, and their heart rate ranges from 120 to 160. It will be varying. So that is what we can conclude from this graph. Next is CrossStat. Here I have used for resting electrocardiogram and target. So for you can see that for 0, 1, 2 is the resting cardiogram, electrocardiogram. If it is 0, it means your electrocardium, that is the ECG, is normal. And if it is 1, you are a little severe, I mean the initial stages. If it is 2, it is severe case. And when target is 0 and 1, obviously 0 is absence of heart disease and 1 is presence of heart disease. So we can conclude that there are 79 instances in your data set who have normal electrocardiogram and they do not have heart disease. So here we have 68. 68 means their electrocardiogram is normal, but still they have the heart disease. So in that way we can analyze this data. Next I have just found the mean of that data, and similarly I have done the cross tabulation. Here import SCIPY, it is scientific Python. So from that what we have analyzed is, we have the statistics comes in negative, p-value is given, analyzed, and df is also given. That we can check in the cross tab only. So here the cross tabulation is next done for the heart rate and the gender. That is whether female or male individuals, they have what range of heart rate they have, whether maximum or minimum. Now this is T2 contingency. So in this, because the p-value is 0.03, it means that it is lesser than 0.05. So if it is lesser, it means that whatever the two variables you have passed, it is related. It is associated with each other. If it is above 0.05 p-value, it means that there is no dependency or no associativity with those two variables. So in our case, it was heart rate and gender. So obviously female will have more heart rate when compared to male. That is what we can conclude from that data set. And now I have found the correlation matrix. So negative correlation matrix, in a sense, obviously in diagonal will have one only because it is going to be the same. If negative correlation, in a sense, if one value increases, other value will decrease, and if you have positive, it means that both the values will increase or decrease together, like simultaneously. And this is the heat map. The heat map has, it looks a little congested because the values are like that in your correlation matrix. And you can see that red is to negative correlation you have, and green is positive correlation to the extent, and yellow is intermediate of both. So you can see the diagonals are always 1. So this is similar to what we saw in matrix. So we saw in matrix form, and the same thing using color differentiation and heat map, will be able to see the variation obviously. And you can see negative correlations, and also green as positive. Variance of red is there, and variance of green to indicate that whether it is intermediary or 2 maximum, 2 minimum, that we can check it out here. So application, so that is about my data set. So application of this heart disease data set is in medical field, mostly in medical field, and also for individuals also, like based on their blood pressure fluctuating or their cholesterol levels, blood sugar, we can ourselves also determine whether there is presence of heart disease or not, or we are more riskier to get the heart disease, and this is used mostly in medical field. Thank you.